So in this video, we're going to try to solve a problem. So let's read the problem. A block with mass large M lies on a slippery horizontal surface. That means we're going to take note of that one. Slippery horizontal surface meaning we're going to deal with the system with like frictionless system. Frictionless. So that means we're not going to consider the forces done by friction because this is slippery. So on top of it, there is another block with mass small m, this one. This block with mass small m is on top of the large the large block with mass large M, which in turn is attached to an identical block by a string. So this is a string. It's attached to a different block which is identical to its mass. Identical means they have the same mass. And the string has been pulled across a pulley situated at the corner of the big block, and the second small block is hanging vertically. So this small block with mass small m is hanging vertically. Initially, the system is held at rest, and we're gonna go find the acceleration of the big block immediately after the system is released. So you may neglect the friction, which we actually already like written, as well as the masses of the string and the pulley. So we'll neglect the mass of pulley and the mass of the string. So the first thing we're gonna do is to investigate their actions, their movement. So this is the big block with capital M mass. So if and this is the block with mass small m on top of it, and this one is the identical block with mass m hanging vertically. So let's go investigate the motion. If we release it, we release the system, obviously this mass here will go down and will accelerate downward because of gravitational pull. So we'll name this as A2. We'll name that A2, and we'll name this as A1. The acceleration of the small block with mass m on top of the big block. So A1 is the acceleration of top block m. That's relative to ground, because we're gonna have to indicate this one, because if we don't indicate this one, the acceleration of block on top of the big block is varying depending on our reference. If our reference is the stationary ground, its acceleration is a1, we'll let it a1. But in reference, in relative to big block, its acceleration is different. Okay, so we'll have to make some reference, which is the ground, and it's stationary. And A2 is the acceleration, vertical acceleration of this block here going downward. Acceleration of the hanging block. It should be downward. And T obviously is the tension of the string. Tension of the string. And we also consider the acceleration of the big block. So we'll call it a capital M, AM. Okay, so if this accelerates downward, this block here, if these moves downward, and obviously this also will move to the right, this block here. And because of this, after releasing the system, your big block will move to the left, and we call that AM. Okay, so that's the acceleration of the big block M. That's to the left. Okay, so let's go examine their individual free body diagram. So let's start with small block on top of the big block M. So let's go. We have the normal force, we have its weight mg, and we have its tension. So these are the forces acting on the block that is on top of the big block. Okay, that's FBD1. And let's go FBD2, the hanging block. So the forces that are acting on this mass is the tension, obviously, and its weight, which is mg. Okay, so these are the only forces that act on these hanging object. So let's go with the large M. The forces acting is the normal force that acted on M, the large block, and its weight. And also we have the force F. So this F here now is the same value as the tension. Why is it the same value of the tension? Because as this one here, as this block is moving to the right, this will also exert a force opposite to the tension, right? So if this is your tension here, we have this is big M and this is small m. And if this is moving to the right, so this object also on top of the big M will exert a force to the M, which is opposite to T. So that's why we have F is equal to T. So this is just the action reaction. This is the reaction it gets if M is moving to the right. Okay? If this small m moves to the right, this creates a force and a reaction opposite to this force, which is the tension. So F is basically T, so we'll just put T here. So let's go and try to solve for some formulas. Look for the formulas that we'll be using to solve for the problem. So let's go delete this first. So remember those notations. We're gonna delete this as well. Okay, now let's go solve for the first FBD, which is the FBD or the free body diagram of the small mass M, this block here on top of the big M. So we have a tension here, we have tension T, and it's moving directly towards the right with acceleration of A1, right? So if that has force tension exerting on this object and it's moving in this direction, it's accelerating in this direction, then according to Newton's second law of motion, our T is just the product of its mass and its acceleration. So we have equation 1. Okay, we have equation 1. So this is because of this one. So next, we'll find an equation using the block small m moving vertically downward with acceleration a2. So the forces acting on this object are tension and its weight mg, right? So we can simply put an equation T or mg minus T is equal to its mass times acceleration, right? This is Newton's second law of motion. So we have positive mg here because it's the same direction as its acceleration, right? If this is moving downward, then we put positive here in mg and negative in tension. But if it moves upward, then we'll have the positive d minus mg, but that's not the case. So we have this one, equation 2, and we also have the free body diagram of the big block, which is accelerating towards the left with acceleration am, and the forces acting on it are, again, we solve it already, is the tension, right? The tension. So we have T is equal to mass m. Take note of the mass, it's now bigger, and am, which is the acceleration of the big block. So we have our equation 3. Okay, so if our big block m is stationary, we would have the same acceleration a1 and a2. So we can actually plug this in directly here. But basically, we don't have the same value for our a1 and a2. We could have like substituted mg minus t. This is equation 2 is equal to, this is ma2. And we could actually, if this was stationary, this is stationary big block with mass large M. So mg minus t is equal to ma2, right? And we could have make this like this one, a1 is equal to ma2, right? And we can just make this m a1 plus a2, g is equal to a1 plus a2, or g over 2, its acceleration. The acceleration of these two small objects is g over 2, but this is not the case because our m is not stationary, so we would not do this. I just showed you like what if this big M here is stationary, so we would have done these instead. We just substitute ma1 in here in C and solve for its acceleration, which is the same for both. But this is not the case because a1 is relative and we have a reference, the ground. A1 would not be moving, like A1 is not equal to A2 since AM, or the big block with mass M, is also moving to the left, right? So A1 is not that case. A1 is not equal to A2. So we'll go look for an equation. So the equation would be, let's go our fourth equation. Let's go for our fourth equation, which is not a1 is equal to a2, of course. So the acceleration here at the top, is just equal to the acceleration a2 minus the acceleration of big block, right? So if these block here moves to the left and this big block here carries this small block, then that means this A1 relative to ground, relative to our stationary reference, which is the ground, actually decelerates by an amount of AM, right? If this moves to the right, which is basically A2, because they're attached with strings and this string is inextensible, so that means this also should move A2 with respect to relative to big block. But what if relative to ground? So relative to the stationary, your A1 is equal to A2 minus AM, right? This moves A2 here, acceleration, and this moves A2 relative to the big block M. But if relative to ground, since M is already also moving towards left with acceleration am, then you just subtract a2 minus am. So this is now our acceleration, a1, acceleration of the block on the top of the big mass m. That's clear, right? So now let's go to, this is now our equation 4. Let's now solve for, what are we actually looking for is am, right? So we'll go solve for am using these four equations. So let's go solve for using the equation 1 and equation 3. Equation 1 is T is equal to MA1, and equation 3 is equal to large MAM. So let's go solve for AM in terms of small m, large M, and AM. So MA1 is equal to large M, AM. A1 now is equal to M over small m, AM. So we now have equation 5. The next thing is we use equation 2 and equation 3. So that's mg minus our t is just this, MAM, we substitute MAM is equal to MA2. Okay? So we have this large M, AM, and A2. So this is now our equation 6 in terms of AM and A2. Next, we'll go use our equation 5, which is this one, and equation 4. Okay? We'll go substitute or plug this in A1 here. This is A1, so that's M over small m. AM is equal to A2 minus AM. So this is just M over M plus 1, because we can actually move this to the left hand side of the equation. And we will have, in terms of equations, equation containing AM and A2. So that's what we want, the AM and A2 to remain like this equation 6. So we have equation 7. So now we can actually plug in these equation 7, and equation 6. Okay, use A2 here and plug that in here, equation 6. Mg minus M AM is equal to M times M over M plus 1 AM. See, we're now left with AM only, so we're just gonna solve for that. Let's go solve for that one. Where are we gonna solve? So let's go. Mg is equal to M AM plus, so we can actually distribute this one, so we'll have M plus M AM. So now we have Mg is equal to M plus small m AM. So our AM is actually Mg over 2m plus m. So this is now the acceleration of our big block with mass m, which is directed towards the left. This is directed towards the left, and its magnitude is mg all over 2m plus m. So that's it. Thank you for watching my video.